Today in college algebra, we wrapped up zeros of polynomial functions. Yesterday, we started by looking at this formula at the top of the page, how to find the possible rational zeros. And we just looked at 1 and 2. Right now, we're going to look at number 3 and find how to completely find complete the problem. Instead of just looking at possible zeros, we're going to find the actual zeros. So we start with what we did yesterday by writing factors of -6 and factors of 1. And remember, the reason why I picked those is because this is our lead coefficient, 1, and -6 is our constant, and you divide the two. And that gives you the possible zeros. So I'm going to write out the factors of -6, and that would be positive -1, positive -2, positive -3, and positive -6. Factors of 1 is very easy, just positive -1. And when I divide by 1, divide all those factors of 6 by 1, I just get the same exact list I have at the top there. Just be careful if the lead coefficient isn't a 1, this list is going to be longer. All right, I have my possible zeros, and now I want to literally guess out of those 8 numbers. We have 8 numbers here, right? Positive, negative. So you literally guess, and I'm going to do synthetic division and see which one gives me a remainder of 0. So for example, let's pick positive 1. And I write down the coefficients of my polynomial. So remember, there's a 1 up here. There's a 2, there's a -5, and a -6. So we have 1, 2, -5, and -6. Double check your signs, because one little mistake and this whole thing goes badly. All right, I drop the 1 straight down, and I multiply whatever's below the line times the number in the bracket. So 1, combine, and I get 3. And now I go 3 times the number in the bracket. Get -2. And I get -8. This was, let me explain, this is not a 0 because the remainder is not 0. That's the remainder right there. All right, let's try another one. Maybe try -1. We have 8 guesses. Unfortunately, we could be here guessing through all 8 of them, but hopefully we'll find it faster than that, and we'll go a little faster now. So 1, 2, -5, -6. And this one works. I got 0. So down here, I know one of my answers is -1. If you look up at the original problem, it says x to the 3rd. That means we have a possible 3 answers. So we have 4 more guesses we could do, or I'm sorry, 6 more guesses. And there are 2 more answers. Another way to do it without having to guess is, since that was x to the 3rd, like the largest exponent, this has a largest exponent of x squared. So that 1 right there symbolizes 1x squared. That middle one represents 1x minus 6. And if you can factor it, then you have the other 2 answers. And I think that's factorable. X plus 3, x minus 2, I know that negative 3 is a 0, and so is 2. So what that says is if I had guessed negative 3 earlier, I would have gotten a remainder of 0. If I had guessed 2, I would have gotten a remainder of 0. And there's just always more than one way to get to the right answer. So there's a couple of ways. Hopefully that makes sense to you. Number 4 is very different. We start the same way, but you could be here for quite a while. So maybe write down your possible zeros, or hit pause and write down your possible zeros. I'm going to write them down here. And I think you're probably noticing we have a lot of guessing to do because there are many factors of 24. I'm going to write them all down real quick. So all of these numbers divide into 24. 1 is nice and easy. That's just plus minus 1. Possible zeros, I divide by 1, and I get that original list at the top. So I'm just going to rewrite that. And now we guess. You got to guess which one. This could take quite a while. We have 16 possible guesses. Since it's x to the 4th, we have 4 possible answers. Now there is a chance some of them are imaginary, because if something isn't factorable, then we have imaginary or irrational zeros. So I'm going to guess negative 2 to start out. And something else happens on this problem, because if I start to write the coefficients of that typed problem at the top, notice it's missing x cubed. That's bad for synthetic division. I need a placeholder for every exponent. So I'm going to put a 0 where an x cubed should be as like a placeholder. So I have a 1, I have a 0, negative 6, negative 8, and 24. If you're lost, look at the very top of the screen. I wrote down all the coefficients, missing the x cubed term, so I had to put a 0 in its place. And then I do synthetic division. Drop the 1 down. Oh, this isn't looking promising. 32. So I'll be honest, this is a lot of guessing. I'm going to just give you the answer right away. 2 should work. So let's show that that one works. And sure enough, it does. This is a weird part, though. So I know one answer is x equals 2. So that's nice. I have that. But I have some choices. I can keep guessing out of those 16 numbers up there, or I can take this result and write that as x cubed plus 2x squared minus 2x minus 12, and start this whole process over again with factors of negative 12. It's up to you. You can keep on dividing with our original list, but we just narrowed it down a tiny bit with negative 12. Either way, it turns into a load of work, and I'm going to show you a shortcut. I sat here and I divided all these numbers, and I just happened out of curiosity to try 2 again, and 2 happens to work again. Now I'm writing the coefficients down from that equation at the bottom of the screen. So I got a 1, a 2, a negative 2, and a negative 12. And it checks out, which is kind of weird because we already knew 2 was an answer. What that means is that x minus 2 squared is a factor. And the other factor is this, which is not factorable. Now what we could do if we were really wanting to see all the correct answers, we could plug that into quadratic formula and find the others. They're either imaginary or irrational, but this is the only rational answer. So I usually write something like the rest are imaginary. I guess they could also be irrational, but either way, we can't find them by factoring or synthetic division. So you're done. All right, let's try one more. This one's a tad faster. It's not as ugly as the last. So we have factors of 4. Oops. Let me fix that. Okay. Factors of 4. Factors of 1. And possible zeros. You should hit pause and see if you can do this on your own without me, and then check your work. Factors of 4, we have plus minus 1, plus minus 2, plus minus 4. Factors of 1 are plus minus 1. Divide the top list by the bottom, and I just get a repeat of that top list, because I'm just dividing by 1. So we're going to speed this up a little bit, and I'll show you the correct guess. But feel free to pause it and try some of the answers. If we try negative 1, that will work. Write down your coefficients. Do some synthetic division. And it checks out. This one's kind of similar to the last one in that we're done. Because when I write down this in polynomial form, I see that it is not factorable. There are not 2 numbers that multiply to 4, but add up to 1. So we're done. That's it. The rest are imaginary or irrational. All right, I hope that made sense. See you later.